Welcome back to part 2 on our journey to implement version key value stores for the library kafka-streams-cassandra-state-store. In part 1, we created the data schema and played through examples and made sure we have a solid way of solving all the needs of the versioned key value store interface to implement our code in the end. And in part 2, I'm going to, simply add integration tests for version key value stores, so we can then write our actual store implementation against those tests. So let's start. This is issue number 21. Adding version key value stores. Let's create a new branch and get started. So in the main module, we have a package integration test where we currently have, an abstract integration test and then 3 integration tests. And I think I'm just going to start and copy this one to get started. And let's stick with the partition. Let's say partitioned version key value store test. Let's just make it start with that name. Can always rename later. Okay, I think I'm going to just clean up and strip all the unnecessary bits. We don't need all of those complicated parts, so I think I will just go for a single input topic. We will go for that meal prices example. So we have an input topic where we get in, let's just keep it all. Say this is prices. And then we have a store name, meal prices. And let's simply start with the stream. So I think we can get rid of the stream. We can get rid of all of that. And let's just say we want builder table. Topic is our input topic. And then we go materialize as store name. And we're going to implement the test using the existing RocksDB implementation. And in the next part of this live coding series, we are then going to switch and add our own implementation. So we're going to go for stores. Persistent versioned key value store. Simply with the store name. Not sure if we need both of. He needed in 2 places. Also get rid of this, probably. Store name and we say of seconds, 30 seconds retention, history retention. Not sure which is the cleanest. It would be the cleanest bit, and I think we might need to tell the materialized part with key serde, it's a string serde, and value serde would be long serde. I mean, you wouldn't use long for prices, I guess, but in this basic example, I'm just going to build on top of the example provided in the talk. I think that would be easiest to work with that as a reference. And here we only have like full prices, so I'm just gonna take it easy and have longs in kind of dollars as the price for the meal. And here it's complaining object. I think here we need to define string long. And here we go. I think we're good with that. And just that as a reference. This one as a reference. So we simply built a KTable materialized as a persistent version key value store, which will choose the RocksDB persistence with a history retention of 30 seconds. And we will simply consume an input topic with keys as string keys, which is the meal name, and prices as longs as the value. And I will just keep passing in the CQL session because we obviously will need that once we switch out persistent version key value store with the future to implement Cassandra version key value store. And so I'll just keep that as a reference, and let's continue with defining a first test. Okay. I think the first test would be we're just simply gonna, well, let's just do all of that in a single test. We're writing integration tests, so we don't need to do everything too fine granular. So I think I will just do sort of the get. I will ignore the put for now, but I will create the input data, build up the state as it is at this point in time. Might need to see how I tweak the stream time. Maybe I'll just send a second value to ensure that we are in that same state. And yep, let's just get started and write a test for should return, should allow get records from version store. Okay, let's stick with this for now. I think the input values are going to be more complex. Obviously, it's not just a list of values, but we will need a key and value and also record time. So though the key we will always use the same key, so I think I will just make that similar like that expected word count. I think I will just use that as input values. I'll just make it long, and we simply say at the time. So the first one will be the time. Input values or input values by record timestamp. And let's simply then put in at the time 0, price is $8. And then we have at the time that probably for $10, at time 17, $12. Then we get at time 38, $11, and 53, $9. What was it? $11 and $9. And I think to ensure the stream time also advances to 64, I think I also need, can I do a long, let's change that to a long and pair. Tuple pair. So many choices. Not using Kotlin. Let's just go for a pair using Apache Commons, which seems we have on the class path. So why not? Do we have another pair already in the import? Why does it not import this? No, complaining what? Cannot resolve. Test containers shaded. Well, test containers, I think that might just pick this. It's not that important. So let's say we may make that actually a key value. Pair of query to key to value. This is the record time. Put records by timestamp. Well, it's a map, so if I use the same timestamp twice, that's not exactly ideal. Have we also had just a list of tuple 3? No, nothing on class path. Well, I could have defined an inner class for that as well. Maybe that's even simpler. Test record. I could have defined the records directly. I mean, I'm going to apply and produce records anyway. Maybe that would have been simpler. String key and long price or value. course, this arrays as list, and we say new test record. Okay. Let's see, not sure if that's too complicated, but static private class. We probably need a string and long asserters. We need the properties. We only need to create input topic. And I think I'm simply, for simplicity, just going to use a single partition for this test. Well, I don't think we need to do anything fancy with tasks or threads here. So, right, and why I did all of that effort is to say I want to send at the time 64, I want to send any, any record just to advance the stream time for our streams task. And 64, yeah, I think that should be the stream time, so we can test properly with the history retention. Okay. Let's just also make our let's use test key here to reuse later for the assertions and for querying the store. And so we create a topic. We start streams. And for our input records, we're going to produce new records to our input topic. We use key, the value, and also now we don't, we need to pass in the timestamp as well. What's the right constructor to use? Topic, partition, timestamp, key value. I think the partition can be null to be determined by the partitioner. And then we have timestamp, key value. Why does it still complain? Producer record is string, where it's this defined. Provided string long. Is the producer. The producer is string. I think then, yeah, it should fix it. So we have a producer. We actually don't need a consumer. We will need the CQL session and streams. Okay, so we create a topic. We start streams. We produce all of our input data. Now, question, when is this processed? Not sure. Maybe we should actually also have an output topic. Simply send out what comes in. We'll also send out, but that's not really necessary for the test. Though we would need to ensure we wait until the data has been processed. Not quite sure how we can do that. Maybe through an output topic would be best. I'm not sure if we can check the entries from the store. Let's just try with the approximate number of entries. Though I'm not sure if that will, since it's approximate, if that will be a match, but let's try if that's gonna work. Okay, now we need okay, we get the store instance. Now we don't need our don't use our fancy interactive queries thing, but just do the regular way stream store from name and type. We have our store name and we have a versioned. Is this right? Variable state store type. Let me check if that's actually used in any of the. I did a bit of research trying to find tests from the official implementation or from Confluent, but I wasn't able to find any integration tests I can just take as it is. So I decided to write my own test logic. So from name and type, variable store type, let's just see value store type. Read-only key value store. Is there a read-only? But we should have access to the version key value store. Is this not queryable? Extend state store. So there's no interactive query support at all. That would make it at least harder to test, since I was planning to simply use the store to get data to evaluate if that's working. Let me check the RocksDB versioned store interface that implements version key value store, implement state store. Okay, but there's no, so that it's not implementing any read-only or interactive queries interface. So there actually is no interactive query interface at all provided yet with the current KIP. Okay, that makes my efforts to write tests and access the store to verify a bit more complex, since I think everything wouldn't need to be done via joins, for example, using a stream to table join to verify, to test the point in time records. Or, gosh, that making it a bit more read only. Okay. Okay, so I think there's nothing we can do, so that will make it a bit more tricky to test. So means more effort, but it should still be doable, I guess. Though I'm not quite sure if. I think it will definitely be a bit more messy to produce state and okay. I think we'll then need to work with a join. So let's just go ahead and do that. Let me clean up first, and let's get back that logic for the consumer. And okay, let's start it straight away. So we simply need an out. Now we need an input topic orders, and we rename this to input topic prices. And keep the store name, and we will have an output topic price orders. Okay, so let's first fix our topology. So we have a table. Now we have a stream with orders. Build stream from orders. And orders would be, how do we structure the orders? I think it would need any key, doesn't matter probably. Let's simply make the value simply the meal name, so it's not, yeah, it's just single orders of single menu items or meals. So let's just make it a string stream. And now I was not prepared for this, so let's say we just join orders to our work. Why does it not work? Oh. This is prices. So we join our prices stream. And I think we will need a new, what are we going to output? I think simply the price at the point in time of the order. And as the key, we are gonna simply use the meal name. Okay, so we join prices. We're simply gonna use it should be keyed identically. Can we simply send the key as the, for the orders, we'll simply send key value both with the meal name. So I think the join should work straight away without any repartitioning. So let's do, I think we simply need the values in that case. And we should return, oh gosh, value joiner returns a new join value type. And we join orders prices. So this should be string. This is our long. So we just return value 2. So this is the, this is the price. Return the price. And we send this to the output topic. Long way to go. I'm not sure if those comments really help, for it's obviously clear what this is. Orders stream. Okay, so we have a new topology where we get prices in with query to like price, and then we have orders where we just send the meal name both as key and a value for the sake of this test. Otherwise it might not make sense. And then we join them together based on the key, which will allow the join to match without any extra fancy rekeying or repartitioning. And key selectors, and then we simply take price. And since our table is a versioned table, I wonder if this is going to return, is this a K? There's no version table, right? This is just going to work as it should, with not always using the latest, but the point in time value for the join. And then we emit this on the output topic. So the output topic will have will look the same as prices topic. We will have a key, the meal name as a key, and the price at that point in time when the order was sent. So that's the new topology. Now we need to bring back this consumer pattern I've had before. And we need another producer and more test data for the orders as well. So those are actually input prices, and we also want to have input orders by timestamp. Here our test record. Let's make this now a price. And do also like an order where we have not sure if that's easier or if we should just use objects for key value. I think that would probably be simpler. Or we should use records straight away. Nah, that's also not great. Oh, why not? Maybe that's even easier to produce a record. Let's just drop all of this extra. Are we going to need it for consuming data as well? No, I don't think so. Okay, list producer record. Input. We need to. Well, let's send everything through at the same time and verify the output. And I think we can then still no, I think we should send let's keep it separate. So input prices and input orders. And I think we'll need to send the orders first. Let's also put them, no, the prices first, of course. So we're simply gonna do new producer record, timestamp key value. Yep, it's good. And then we do the same. Value, this is going to be string long, to be exact. Why not? And we will have string for orders. And then also prices. Just here orders, put topic orders. And we're going to use the test key. I think we won't need let's still make sure the stream time is at time 64. And let's now send in, use the test key also as the value. This should be our orders. Well, no, I think the orders we need to construct from the test cases, of course. So we want to get the latest. So we simply make that as, not sure how to do well, let's just keep that order as it is. So the latest would be at time 64. We send an order in. Then the next test is at time 60. Time 50. 35. 30. Those are our orders. We test in this sequence, orders in this order. So we, for each, send it. So we first send the prices. Then we send the orders. Well, we have two. We need. This is now our. Do we need to prices producer? Orders producer. Okay, so we'll need string orders producer. We send in all the input data, and then we can start. We should consume our output topic and then verify all of the expected values. Okay, let's consumer subscribe. What is this? Right, that's at the top. Priced orders, and we also need to bring back this consumer. Consume and collect the stream output. And we do, right, results is right here. Okay, expected put expected messages. Well, maybe better to place it in here directly. So I think we would, I'm not quite sure with the null if it would just get ignored. I think so. So we would expect 1, 2, 3, 4 messages. Let's try with that. And then I'm really looking forward to running this at the first time. So assert that oh god, this should be assertions. asserted results, get our first result, or let's just start asserted results, size. Why did it now remove this again? Is equal to, so the size should be 4. And first get get not a map. We need to collect, obviously not as a map, but this should be a list. A list of a pair of string long. Or we can also use key value from Kafka Streams. Why not? It's essentially the same thing. New array list. So, and results, we say add key value of a pair, like a key value. And now we can say our first entry is equal to our first expected result would be curry $9, test key 9. And it's a bit, not sure if that's beautiful to do it like this, but yeah, I think at least to get started and see if this even runs and passes, let's do it like this. So then we expect $9, $11, $12. Okay, that should compile, and Docker is running. Let's just go for it and see if that's gonna work out. Error. This can't be good. I think the streams topology has some issues. Oh. A noun topic. Did I not create all the topics? That would be quick to solve at least. Why is this so? Okay, I think I will simply need to create all of our topics, orders, put topic, and let's run that again. Error again. Okay. In producer, This key is null. Hmm. Hmm. Let's try to debug maybe when are the producers used. Partition null. The key should never be null. I'm not sure why it's complaining with this. Let's see how far we get. Hmm. Let's start in debug mode. Okay, consume. Input send. Order send. I think the streams itself fails. Is there an issue with the topology? Let's see if we can get into the lambda for the join. And then do we have any problem with do we need to set serders here or anything like this? String long. Ah, right, produced with. Probably need to add this. Let's also add a peak. Okay, I think I will just try again, not in debug, but let's straight away run it and hope this has fixed producing the outputs. No, not yet. Key is null. Why is the key null? Do I need to? Does it get lost if I just do a value joiner? Ah, sorry. to return the stream table. Okay, I think the key is getting lost. Where you join up with key, but this also returns a value only. But why is the key? The key should not get lost on the way. Okay, stream string long. Did we get this out? Okay, why would the key be null? Does this happen when 9, 9, 11, 12, 12? 9, 9, 11, 12. Okay, well, I think that retention and maybe the record did not expire properly. Maybe I should actually send this any record on the orders topic rather than here. To advance the stream time. And I'm still not sure though why it would complain about a null key. Null pointer at size. This key is null. But this is way before to the IO thread. I think it did process. Maybe we can ignore this and the assertions. The assertions are off. So maybe it will be fixed with advancing the stream time like this. Ah, wait, we need to first. No, it should already. The stream time should already advance with this record, the first one, the first record sent anyway. So I think the problem is this last lookup at time 30, where we would expect, according to this test, that join should return null and should not succeed because the history retention has passed. Maybe that was let's try with an earlier timestamp, like at time 10. Timestamp 10. And let's run this with the debug again. I think it would be interesting to see the results. that came in. Okay. Okay, we have again no input orders. Results. Okay, we have 5 results again. We got $9, $9, 11, 12, and then $10, which is the price at the time 10. So it's correct from the point of versioning, but it should, not sure when that cleanup happens if this is not correctly handled as described. Let's take a look again at the versioned key value store interface. Versioned state, no, version, project files, libraries, version key value store. If we look at our get as of timestamp, it says value and timestamp of the record associated with this key or null. If no such record exists, including if the provided timestamp bound is older than it stores history retention time. If it no longer contains data. If the latest record version of the key is eligible for the provided timestamp. Okay, no, this is only the latest record. Not sure. Okay, I think I'm not, maybe it's not RocksDB. Not sure if we now need to read the code or if we just take it as it is. As of timestamp should be smaller than the observed stream time. Okay, maybe we can debug into here and check why this does not. I think it should apply, otherwise return null. Okay, let's run that again and see what we get here. Okay, as of timestamp. Oh gosh, I was just working. Longs again as timestamp. Oh no, okay, the observed stream time actually is 53. Okay. And the history retention, but the history retention is in milliseconds, not in seconds. So I think it's the same mistake I made last time in part 1 briefly. So okay, I think that should be easy to fix. Let's just stop it here. And either I think we can also set the off seconds, not 30 seconds, but let's just say off millis, 30 millis. Then it's easier to read. It's a bit extreme. Why not? And then let's just revert also our last test order to check, like in the original example, the 30. And yeah, let's run one more time in debug. Let's debug here once again. Yep, historyRetention. Okay, let's step out. Now let's see, we got 5 results again. Okay, and we got again another, for the last record, we got, but the observed stream time was 53. 53 minus 30 is 23. So the 30 is still in the valid range. So I think the issue now is, why is the stream time, the observed stream time, 53 and not 64? Because we should already have processed an order at the time 64. So when we reach this order, we should have an observed stream time of 64 actually. At least that's what I would expect. Oops. Okay, let's debug again and look at all of our store accesses, which should be 5. Not only at the first. Okay, the first is observed stream time 53. That should be fine, because when this record is processed, I think the latest known might be this. So let's see when the next order is actually processed, if the observed stream time changes. So for the next step, now we check 60, 50, 35. Okay, that observed stream time does not change. Though I'm not sure why that is. So if we put our, let's put here again our any key at the time 64. Let's see if that makes a difference. To advance the stream time accordingly. No, observed stream time still is 53. Is this? No, I thought I created. Is this the stream time by key? No, that can't be. It should be by streams or by partition or streams task. Task 0. Partition 0. Put. Let me double check again that. So I'm creating new topics with one partition only. So I think there should only be one stream time per task, or per, and since the single task has a single partition assigned. I'm not sure if the stream time is actually per topic. You put topic and not overall topology task. But that would also be odd. Then it should advance while processing orders. What happens if I set just the same price at time 64. Okay, now observed stream time again is 53. And it also doesn't change. Okay, I think I'm simply gonna give up. I can't really explain why it behaves like this. I will keep it here. Okay, not sure. So let's change that to not 30 but 20. And at least then it should be smaller than 53 minus 30. So let's try that again with this and see if now our assertions pass. Now we got 4 results, 9, 9, 11, 12. So if we now continue, we should get our green test passing. Okay, this was taking a lot longer than expected because we need to work with a stream to table join and cannot access our store directly. That makes everything a bit extra complicated to test. I'm not sure if it's actually easier to test. It would be easier to test not with test container setup, but I will need that in the end for the Cassandra state store, and I'm not sure if I can actually test a state store with actual RocksDB and the underlying RocksDB without a topology and running streams. I don't think that can be mocked easily. And I cannot use the topology test driver. Maybe I could, but okay, so that's just one first test, and it took quite long to set up, longer than expected, and it's more complex than expected. So I think we can still build on top of that to test, like putting a new latest record, then send another order, deleting, and then putting a point in time, like a late arriving order. Well, all of those are essentially arriving late because we are already behind. And yep, I think I will take a short break, or maybe I will actually do that in a part 3 and build more test cases. But I think that's at least a first state with an integration test in kind of my test container setup, where yeah, I think it would be good to add additional tests for the various edge cases to cover, yeah, all of those in a bit more detail in kind of multi-step producing input data and asserting or consuming and then asserting the output messages. So I think I will take a break here and at least wrap up the recording at this point in time, and then decide later if I will continue or do it in a part 3 to build more integration tests. Okay, if I think, yeah, that's it. Bye-bye. Thanks again for tuning in. Subscribe to my channel, and please share with your colleagues, follow me on Twitter to build up kind of more listeners and community. Thank you, and goodbye.